It begins in the dew-covered groves of coastal orchards at 5 a.m., where the air is so sharp with citrus oil it feels electric.
Factory doesn't source from just anywhere. These orchards are located in specific coastal microclimates where the mist from the ocean provides natural humidity.
And temples. The first half of the cake's soul comes from the Eureka lemon. Originating in California, this variety is the gold standard for industrial
Lemons. The acidic punch, Lisbon lemons.
They work with surgical precision, using specialized hand snips. Snipping the stem flush with the fruit.
The factory uses a color matching system called the Solar Yellow Index. Pickers carry color swatches to ensure they... A lemon is composed of the flavido, the albedo, and the vesicles hef. The factory's goal is to harvest...
Inside that yellow skin are thousands of microscopic oil sacs. If a lemon is dropped or bruised during
The 5 a.m. start time isn't just about beating the heat, it's about turgor pressure. In the early morning, the lemons are at their most hydrated.
the race against time, the 48-hour rule. The moment a lemon is snipped from the tree, a death clock starts.
By 9 a.m., the orchard's loading bay is a flurry of activity. Crates weighing thousands of pounds are moved via electric forklifts.
The lemons don't travel in open trucks. They are loaded into refrigerated reefer containers set to exactly 7.
These compounds are extremely delicate. If the harvest temperature spikes, these VOCs are lost to the atmosphere, and the resulting cake will taste flat.
We often think of factories as places of steel and oil, but this factory's heartbeat is biological.
As the trucks pull away from the coastal groves and head toward the gleaming steel gates of the factory,
the first stage of cleaning is the pre-rinse shower. High-pressure nozzles blast the lemons with chilled, ozonated water.
cavitation, the microscopic scrub. Inside the tank, the sound waves create a process called cavitation.
The optical sorter. The AI brain next uses artificial intelligence trained on millions of images of lemons to decide which fruit is worthy.
As each lemon rolls through the chamber, it is hit by high-intensity LED strobes.
The AI uses infrared sensors to look beneath the skin. It searches for bruise signatures, internal soft spots where the
The most satisfying part of the process is the rejection sequence. A precise, high-pressure pneumatic blast
What remains on the belt is the top 10% of the harvest, the Grade A Elite. These lemons are identical in size, color, weight, and texture.
The purified, sorted, and perfected lemons now move on to a final, high-speed elevator belt that carries them toward. The lemons enter this spinning vortex, where centrifugal force pins them against the walls, beginning a high-speed
To understand the factory's mission, you have to look at the anatomy of the fruit. The skin is divided into two layers, the
surgical shave, precision depth control. The abrasion chamber doesn't just grind the fruit, it uses dynamic depth sensors.
To prevent this, the factory employs a zero-pith protocol, where the zest is scanned by UV light to detect.
This high-speed abrasion creates citrus snow, a fine, dry, fragrant dust. A vacuum-sealed slicer. Once the lemons are zest naked, they move to the juicing manifold. This machine is a vacuum-sealed environment.
The moment lemon juice touches oxygen, oxidation begins. To combat this, the juice travels through.
If the factory environment gets too hot or the processing takes too long, the limonene molecules break apart and the fresh-cut smell disappears forever.
Volatility and the flashpoint of aroma. Limonene is highly volatile, meaning it has a low boiling point and wants to evaporate into the air as quickly as possible.
This recovered pure essence is so potent that a single drop can flavor 10 cakes.
Before the juice and zest are sent to the mixers, a sample is sent to the on-site lab. Scientists measure the
The dry room is a pressurized, climate-controlled environment where humidity is strictly kept below 30%. The architecture of flour. Why cake matters. A cake is only as good as its structure, and in the world illegals. This weakening is actually a benefit. It ensures that when the batter is mixed, the cake doesn't become elastic.
The treatment makes the starch granules more porous, allowing them to absorb more water and, more importantly, more fat.
Ensuring that when the computer calls for 500 kilograms of flour, it flows out with the precision of a digital scale.
In the factory lab, technicians perform a particle size distribution test. They ensure that 95% of the flour particles
The use of ultrafine sugar is the secret to a velvet crumb. As the sugar dissolves, it creates a
Caramelization and the Maillard buffer. Sugar isn't just for sweetness, it's for color. During baking, the sugar on the outside of the cake undergoes caramelization.
The factory uses a dual action system, a precise blend of sodium bicarbonate and mono-calcium phosphate.
Phase 2, the heat-activated rise. The second leavening agent is heat-activated. As the cake enters,
the factory uses food-grade flow agents to ensure the leavening agents stay free-flowing. This ensures that every single
premix integration.
Why are they called planetary mixers? Because the mixing blade follows a dual-path orbit.
The butter is tempered to a precise state, soft enough to yield, but firm enough to hold air.
To the naked eye, it looks like the butter is just getting paler. Under a microscope, however, the sugar crystals are acting like tiny
Phase 3, the egg integration. To make that suspension permanent, we need a bridge. That bridge comes in the form of thousands of pasteurized chilled eggs.
The lecithin molecules lock the ingredients together in a permanent emulsion. The 21 degrees Celsius guardrail. Temperature is the greatest enemy of the mixing hall.
The computer adjusts the RPM of the mixer every second.
Shear force refers to the sliding of one layer of batter over another. The blades are designed with a specific hydraulic profile to maximize shear without bruising the batter.
If the eggs are added too fast, the batter will break or curdle. This looks like cottage cheese and is a disaster for the factory.
It is immediately pumped gently, so as not to pop the bubbles, through silicone tubes toward the volumetric depositors, where it will be measured into pans.
The transition from the mixer to the oven begins at the volumetric depositor. Think of this as a row of giant The pans now disappear into the mouth of the tunnel oven. This is a marvel of industrial thermodynamics.
This intense floor heat hits the chemical leavening agents. The CO2 gas fans rapidly, and the cake springs upward.
Heat is delivered in two ways: forced convection and infrared radiation patterns. Convection ensures the sides of the cake are
At this exact thermal threshold, two things happen. The egg proteins uncoil and link together.
If the oven temperature fluctuates by even 3 degrees during this phase, the cell walls will be too weak and the cake originals.
The final 40 feet of the oven is Zone 3, the Maillard reaction. The temperature is cranked up to its highest point.
The Maillard reaction creates hundreds of new flavor compounds. This provides a nutty or toasty base that acts as
Our core temperature drone transmits real-time data via Bluetooth, ensuring the center of the cake reaches exactly 98 degrees Celsius.
As the cakes bake, they release a massive amount of moisture. If this steam stayed in the oven, the cakes would stew instead of bake.
As the cakes emerge from the 150-foot tunnel, they are a vibrant, uniform golden brown. They are hot, fragile, and smell absolutely incredible.
Factory's cooling gallery is designed to manage this exit heat. They must be perfectly prepared for the next high-tech stage, vacuum infusion.
When the LemonCakes exit the tunnel oven, they are in a state of high thermal flux. They are at their peak temperature.
This machine features a bed of needles, thousands of surgical-grade stainless steel pins. These pins...
The physics of capillary action. By creating these microscopic vertical shafts, the factory utilizes capillary action.
The air pressure is rapidly dropped. This causes the air trapped inside the cake's crumb to expand and escape through the needle.
While the cakes are under vacuum, a high-pressure syrup atomizer activates. It doesn't pour liquid, it creates a fog of lemon simple syrup. Suddenly, the vacuum is released, and the chamber is flooded back with normal atmospheric pressure. This pressure slam pushes the atomized syrup deep into the cake's pores.
The molecular recipe of the soaking syrup. This isn't just sugar and water. The infusion liquid is a proprietary hydrocolloid blend.
Temperature synchronization. The syrup is kept at exactly 65 degrees Celsius. If the syrup is too cold, it becomes too viscous.
Crumb DNA, locking in the moisture. We say the moisture is baked into the DNA because the syrup actually bonds with the starch polymers in the flour.
The sugar concentration in the syrup is calibrated to match the density of the batter. This ensures the liquid stays suspended in the middle of the cake slice rather than succumbing to gravity.
Infusing the cake with sugar syrup serves a dual purpose: moisture and safety. High concentrations of sugar
Weight verification, the absorption test. Every 50th cake is automatically pulled from the line by a robotic arm and placed on a precision digital scale.
The result, a fresh cut sensation. The end result of the soaking station is a cake that...
The glazing waterfall, aesthetic perfection. The 25 degrees Celsius guardrail, thermal equilibrium.
Grease. Titanium dioxide acts as an opacifier that food
As the cake passes through the waterfall, it also moves over a bottoming roller. This small drum sits in a pool of glaze and paints the bottom of the cake.
To refine the look, the cake passes under an air knife. A gentle, low-pressure stream of air sculpts the glaze, removing
Using high-speed cameras to track the exact center of each moving cake, these robots descend in a blur of
Candied crown, positioning the peel. For the premium line, the Delta robot places a single crown of candied lemon peel onto the center of the wet glaze.
The Zest Sprinkle, electrostatic application. The factory uses an electrostatic sprinkler, ensuring perfectly even distribution that looks like it was scattered by hand.
The cakes immediately enter a flash setting tunnel. This chamber uses cold, dry air to rapidly crystallize the top layer of
incense. The final optical aesthetic scanner checks the work. The perfection required here is what builds consumer trust.
The entire goal of Section 8 is to create the artisanal illusion. While the process is 100%
The solution is the ultrasonic cutting manifold. Suspended over the line is a row of titanium blades. Their power
The ultrasonic blade, however, produces 0 crumbs. Every single molling action.
The blades are crafted from grade 5 titanium. This material is chosen because it can withstand the incredible
foods. The cutting head is mounted on a 6-axis robotic arm. This allows the factory to switch between loaf slices,
The laser profile scanner maps the cake's peak, ensuring every slice is the exact same weight. The ultrasonic blade slices through these tough inclusions with the same ease as the soft sponge. The vibrations,
even though the blades vibrate, they are kept cool. The factory uses a Peltier cooling system on the cutting assembly to keep the blade at a neutral temperature.
Instead of grabbing the cake and bruising it, these robots use soft silicone suction cups that gently lift the slice from the top.
The speed of this section is staggering. A single ultrasonic manifold can perform 120 cuts per minute.
The final inspection. The sliced pieces pass under one last vision system. This AI checks the verticality of the cut.
The final seal, preserving the sunshine ultra-clean zone. The sliced cakes enter the final chamber, the ultra-clean zone.
Filtered openers. The process begins with a roll of high-grade plastic film. A machine called a thermoformer heats the plastic and uses
Oxygen is the enemy of the lemon cake. It causes the fats in the butter to go rancid and allows mold to grow.
Once the oxygen is gone, the tunnel performs a gas flush. It replaces the air with a precise mixture of 80% nitrogen and 20% carbon dioxide.
The top film that seals the tray isn't just regular plastic. It is a multi-layer EVV barrier.
A massive heated press descends, putting the top film onto the tray to create a hermetic seal.
If the alarm triggers, a pneumatic arm instantly sweeps the cake into a red bin for destruction.
Limits. If the cake is slightly too small the tray, the X-ray flags it will.
The cakes pass over a scale while moving at 100 feet per minute. If a cake is even 1 gram under the weight listed on the box, it is rejected.
Instead of ink that can smudge CO2, laser best protectors in the batch number directly onto the film.
A robotic arm collates 12 cakes at a time and slides them into a cardboard shipping box. The box is automatically taped and labeled with a smart barcode.
This just-in-time logistics chain is the only way to deliver that fresh from the grove taste to a supermarket that might be 1,000 miles away.
You hear a small hiss of nitrogen escaping. You aren't just eating a cake, you are consuming the result of some of the most advanced food engineering on the planet.